All right, Calculus 2. When I move into section 9.10, we're talking about Taylor series. We're in section 9.10. In the book, it's about page 600 and something. There's a nice little chart that has these famous series. I only wrote down 3. There's a little chart of about 8 or 10 of them. Famous series. E to the x is this. You've heard me say that before. You know, here it is written out. This is the nth term, and it keeps going. So then, you know, if you have the nth term, you can write it as a series. So it's a little redundant here. This is a kind of a long way to write it. But once you have the nth term, the pattern, you can write it as a summation, and there it is. Sine x is this. X minus x cubed over 3 factorial plus x to the 5th over 5 factorial. You know, it's a lot like this. This was a 3 factorial and a 4 factorial. That's what this is. But hold on, the sign just has the odd ones, not the even ones. And the sign alternates, minus, plus, where the e to the x just stays plus, plus, plus. So to get that alternating idea, we get that -1 to the n power. That makes you go plus, minus. And to get these odd numbers, you got x to the 2n plus 1 over 2n plus 1 factorial. So anyway, that's the nth term. Therefore, again, you can write it as a closed series or in the summation form. Here's cosine. Cosine is the even power terms. Again, alternating, plus, minus, but just the even powers, x squared over 2 factorial, x to the 4th over 4 factorial. So that's, I don't know, that's interesting. There it is with the even powers. As n goes from 1 to infinity, that gets you even powers, of course. So these are famous series. Now you, in 9.7, you can build these. In 9.7, you're looking for a Taylor polynomial. If you built a Taylor polynomial, you might have done some homework for cosine or sine or e to the x. We did e to the x. You build a polynomial. You see a pattern. If you see the pattern, you could write it in. You could write an infinite polynomial or a series. So I am going to ask you to build some from 9.7, okay? So you have to do that in some of my assignments says to do that. But once you move to 9.10, there's an easier way to do it. So look, so if I want a series for the cosine of 2x, I go to this cosine function, and what do? I've got a series for the cosine of x. How do I get it for the cosine of 2x? Well, I replace all the x's with a 2x. Now be careful, that means that the whole thing quantity is squared. Do your algebra correctly. The 2x, the whole quantity is to the 4th. And there it is. Now you can go ahead and do it for the nth term if you want. Here, let's go down here. Here it is. It's -1. What am I doing? Replacing the x with a 2x. And there it is. I've just built a series for cosine 2x. What if I wanted x e to the -x? Again, back in 9.7, you take a bunch of derivatives, you build a polynomial. Here, in 9.10, they say use this given series. You've got some given information here. Use that to build this. All right. Let me see. So to get e to the -x, what do? If I have e to the x, I just replace the x with a -x. So hold on a second. I'm trying to build this, but let me do it in stages. If I wanted e to the -x, I would replace, okay, not that. I would replace that with a -x. I'd replace that x with a -x. You know, when you square that, it's still going to be x squared over 2. I replace that x with a -x. When you cube it, it will be negative x cubed over 6, or 3 factorial. Positive x to the 4th over 4 factorial. Negative x to the 5th over 5 factorial. Yeah. And so on. Okay, now what? I want to multiply it by an x. So guess what? If you want to multiply this polynomial by an x, you distribute it and multiply by an x. So here I go. If I multiply this guy by an x, I get x minus x squared plus x cubed over 2. I'm just multiplying by an x, sorry. X to the 4th over 6 plus x to the 5th over 4 factorial, and so on and so on. You know, if I wanted to do it with this closed term, here I am. Let's see, I want to build this a series for this using this. All I got to do is replace that x with a negative x and multiply it by another x. I mean, I think I'm doing that to every term. Every term got replaced with a negative x and then multiplied by an x. So you can easily just do that with the closed form. So here it is. Now you could clean that up a little bit. They would like you to, let's see, you could call that -1 is to the n, -1 to the n, and that x would be to the n plus 1, x to the n plus 1, all over n factorial. There it is. So that's the amazing thing in 9.10. Let me show you something else here. I'm going to erase some of this. I like this question. I'm going to erase a bunch of this. So building new series, given these standard series in the chart in 9.10. So what about this one? There's a lot of good examples, but what about, I like doing this. What if I wanted e to the negative 2x times sine 3x? So that's my function. Well, I want to, and let's say I want a 5th degree polynomial. 5th degree polynomial. All right, this may be tough. This is kind of tough, but I like this kind of question. Well, okay, way back in 9.7, I would build a 5th degree polynomial, taking taking 5 derivatives, blah, blah, blah. These wouldn't be that, it'd be product rules. Anyway, in 9.10, I can do this using this given knowledge. So if I have an e to the x, can you get e to the negative 2x? I think you can. E to the negative 2x would be this guy with the x's replaced with a negative 2x. I'm going to do that. Replacing that x with a negative 2x, replacing this x with a negative 2x, I'm going to go ahead and do that. That's 4x squared over 2. I might simplify that. Replacing this x with a negative 2x and cubing it would be negative 8x cubed over 6. I'm going to keep going. What's the next one? X to the 4th over 4. That's negative 2x to the 4th over 4 factorial. I guess I'll simplify that later. And then finally, I want to go to a 5th degree polynomial. Negative 2x to the 5th over 5 factorial. So I'll stop there. E to the negative 2x taken out to a 5th degree polynomial. Oh, now I want sine 3x taken to a 5th degree polynomial. Well, what am I going to do? I'm going to take the x and replace it with a 3x. Okay, so sine 3x is, there's a 3x. There's a 3x cubed. If you don't mind, that's 27x cubed over 3 factorial, which is 6. Oops, it is minus. It is minus. I'm replacing that with a 3x. Oh my goodness. 3x to the 5th over 5 factorial. Now what I'm really trying to do though is build a series for this. So I think I should multiply these together. Now how do you multiply polynomials? It would be wrong, it would be bad to say, oh, I'll just multiply the first terms and the second terms and the third terms and the fourth terms and the fifth. That's not how you multiply. How do you multiply this long polynomial by this long polynomial? Well, major foiling. Major foiling. Of course, I do want to stop at a 5th degree. So if I get a 6th or a 7th degree, I don't really need that. But that's what my job is now, to build a 5th degree polynomial for this. I think I want to FOIL this out. Here I go. I'm going to try it. I might not finish it, but I'm going to try it. I'm going to take 3x times the 1. That's a 3x. 3x times that's a negative 6x squared. 3x times this. I'm going to do a little, that's a 2, that's going to be a 6x cubed. 3x times this, oh my goodness, I can't, I think it's a negative 4x to the 4th. doing a little math, doing a little simplifying in my head. I can simplify later. In fact, here I am. 3x times this. It's going to be some kind of x to the 5th. What is this? This is 16x to the 4th over 24. Yeah. Well, that's 2/3 times 3x. All right, well, that's 2x to the 5th. All right, that wasn't too bad. I took 3x and I multiplied by everybody. I'm going to stop there because remember, I'm looking for a 5th degree, so I won't go any higher than 5th degree. All right, let's take this guy. Let's multiply him by every term we can in here. Well, this thing times 1 is negative 27/6. That does reduce 9 halves, is that right? 9 halves, x cubed. This thing times the 2. Well, it was a 9 halves, that was a 2, so that's going to be positive, I think that's 9x to the 4th. All right, one more. This guy right here, that's a 2. This is a 9 halves. I think that'll be a negative 9x to the 5th. All right, man, I'm getting there. All right, next term. Let's take this guy, which is, by the way, what is he? He's 81x to the 5th. No, he's not. 3 to the 5th is 243. Now, this is a... that's a 240. This is a 5 times a 4 times a 3 times a 2 times. Oh, I can cancel one of those 3s. That's 81 over 40. 81 40th x to the 5th. Now, what am I doing with that? I'm multiplying by the 1. So I get 81 40th x to the 5th. If I multiply by the 2x, all of a sudden I've got an x to the 6th. I don't want him. Guess what? I'm finished. I am finished. I built a polynomial, a 5th degree polynomial. Now the truth is I'm not finished. You should combine like terms and clean this up. Let's just do that. Let's just do that right above. Oh, and the other fun thing would be to try to graph it and watch it match this guy. But anyway, what is this? Now, if I clean it up a little bit, I built a 5th degree polynomial, but using 9-10 techniques. Here it is. It's 3x. Combine some like terms if you can. That's a negative 6x squared. 6x cubed. There's a 9 halves x cubed. So I can combine those. Everybody knows that's negative 3 halves x cubed. No, it's not. It's positive 3 halves x cubed. It was 6 minus 4 1/2. All right, what about the x to the 4th? Oh my goodness. There's an x to the 4th. There's an x to the 4th. Okay, that's not bad. That's a 5x to the 4th. And finally, the x to the 5th. There's 2 minus 9. That's negative 7 plus this guy, negative 7 plus this 81 40th. Oh my goodness. Oh my goodness. 40, 280, 81. Negative 199 40ths x to the 5th. I think we did it. We built a 5th degree polynomial that matched this function by foiling out these polynomials. I like that problem. All right, good luck. Do some 9-10 homework.